Hello, and welcome to this Tech Byte video. My name is Pablo Salazar, and I'm currently working in CMG as a reservoir simulation engineer. Today, I'm going to talk about the use of layer clumps in simulation models. The objective of this short video is to provide a quick guide on how to create and use layer clumps in your simulation model, option which is available in all CMG simulators, IMAX, GEM, and STARS. In this video, I will be giving a brief overview of the layer clumps option, and I will go through a quick demonstration on how to define them in your simulation dataset using cedit and how to visualize the results. The option of lumping. Having the option of lumping in the simulation model can become very useful when working with fields or reservoirs historically developed by producing or injecting incommingled from multiple zones, where basically there is a big uncertainty on how the historical production and injection can or should be deconvolved among the different stratigraphic units. For example, a situation like the one I am illustrating in this cross-section, where multiple wells are completed or perforated in multiple zones that might or might not be in communication at initial conditions. However, dynamically connected through the wells by commingled production and injection over a relatively long period of time. The option of lumping. Creating lumps in the simulation model can help to untangle the puzzle of commingled production and injection. The keyword layer clump allows you to group a list of well perforation layers into a single unit called a control lump. With each control lump, there is an associated flow restriction or control setting parameter. If the value is 1, which is the default initialization value, there is no effect. If the value is 0, it is like shutting the layers without giving them shut status. Setting values are useful in controlling flow for a set of perforations which share a certain attribute, for example, completion depth. How to use the layer clump option. When you look into the CMG manual, it is explained how to set up this option in your model. And this is what you see in the manual, the format for the layer clump definition and the definitions that are required. In a nutshell, you need 3 basic elements: a name, the well ID, and the UBA location, which is the user block address. Let's see what this means in practice with a short demonstration. Let's assume that I have this data set, which for the purposes of this demonstration is a data set of an IMAX model. What I'm going to do is to open this data set with cedit, so I can manually edit the file to incorporate the layer clump option. Once I open the dataset, I will go directly to the wells and recurrent data section. And in here, I can clearly see that this model have 3 wells defined: oil 1, oil 2, and oil 3. First, we have here the operational conditions defined for each of the wells in terms of production rates and bottom hole flowing pressure. And then, after that, I can see the definition of the geometry and the perforations for each of these wells: oil 1, oil 2, and oil 3. Now, for the purpose of this demonstration, let's assume that we know that this reservoir has 3 identifiable zones or stratigraphic units, as illustrated in the early slides. For example, let's say that in this model, layers 1 and 2 are the blue zone, layers 3 and 4 are the green zone, and layers 5 and 6 are the red zone. Then the question would be, how can I use this model to quantify the production and injection for each of these zones in each well? One way is by using or defining some layer clumps and grouping layer perforations accordingly. For instance, let's define 2 clumps for the well oil 1, one for the green zone and one for the red zone. To do that, The only thing we need to do is to incorporate the definition of that in the dataset anywhere in the recurrent section of this file. So within the dataset, I am going to create a section for the layer clumps. So I'm going to call it Layer Clumps Definition. And we said that we are going to create 2 layer clumps for oil 1. One for the green zone and one for the red zone. So the first layer clump for the well oil 1 in the green zone will be given by the well name, which is oil 1, and the first perforation in this zone, which is the UVA 333, and the second perforation, which is 334. As we said, the green zone in this model is layers 3 and 4. The second layer clump, which is for the red zone, again for the same well oil 1, but in this case we are clumping layers 5 and 6, perforations 335 and 336. Now, for the purpose of illustration, please notice that to define these 2 clumps for this well, I use 2 slightly different formats. However, both have exactly the same effect. My point here is that you can create a clump by listing all the UVAs individually, as I did for the first clump, or you can group them, as I did for the second clump, in layers 5 and 6. Now, let's create a clump for the blue zone, grouping all layer perforations from all the well. As I said before, the blue zone in this example is formed by layers 1 and 2. So let's do that in the same way by incorporating this into the dataset. As you can see, in a clump, you can combine layer perforations from different wells. In this case, wells oil 2 and oil 3 have corresponding perforations into layer 2, which belongs to the blue zone. Okay, so now we have our clumps created, and with this the simulator will calculate the combined production and injection for those groups of layer perforations.